Hello, you are welcome to Physics with Umoru. Today we are going to be looking at the derivation of range of a projectile, and by the end of this lesson I'm going to be asking you a question which I believe you are going to give me the correct answer to the question. Okay, so let's quickly look at a projectile projected from this point, and the projectile had to land here. Let this be the resultant velocity of the projectile, and let uy be the vertical component of the projectile, and ux the horizontal component. Let this be the height of the projectile, and let this be the range which we are about to derive, the range of the projectile. And what is the range? The range of a projectile is the highest or the maximum horizontal distance traveled by the projectile from the point where it is being projected to the point where it returns to the projection plane. Okay, so if t will represent the time taken by this projectile, we already have it from the equation of the motion that s is equal to ut plus half at squared, where s is the distance, u is the velocity, the initial velocity, which could be the vertical component or the horizontal. T is the time taken by the projectile, a is the acceleration, the horizontal acceleration, and t is still the time. So if we are to represent the component of this range, remember that range is a horizontal component. It's horizontal. It has to do with horizontal displacement, or the horizontal distance of the projectile. Okay, so if s is going to represent the range, that is the distance, is going to be the range. U here is going to be the horizontal velocity, because since range had to do with horizontal, so we are going to choose the horizontal component. And the horizontal component of a projectile is given by u cos theta. Okay, then t is the total time taken by the projectile to move from the starting position to this ending position. So t is going to be the total time, which is the time of flight, and the formula for the time of flight is 2u sine theta all over g. Okay, then what else? The acceleration for a projectile, the acceleration is 0. Projectile has a null acceleration. Okay, so if we substitute these values now into this equation, we are going to have it that s, which is r, is equal to u, which is going to be u cos theta, times t, which is time of flight, 2u sine theta all over g, then plus half times a, which is going to be 0, times t squared, which is 2u sine theta all over g, all squared. So because we have 0 here, everything here is going to be 0. So finally r is equal to u cos theta times 2u sine theta all over g. Okay, so if we multiply this by the end, the question I'm going to be asking you now, when you combine this, finally, we'll have it that the formula for the range is equal to u square sine 2 theta all over g. This is the formula for range. Now the question is, how come the range transformed from u cos theta to u sine theta all over g to r equal to u squared sine 2 theta all over g? What happened to the cos? And that is going to be the question. Thank you. We are going to be discussing this in our next video. Thank you.